Graphing linear inequalities. Given any inequality, one may graph it by graphing the function as if it were just an equation, and then picking a point that is not on that line and testing it. If the picked point makes the statement true, then the shading would be on that side of the function line. If the statement is false, then the shading is on the other side of the line. What all of that means is that first you graph the line. And we'll worry about the shading later. So graph the line. Then decide if it's a solid line or a dashed line. Okay, so remember back from previous material, if it is a less than or equal to or greater than or equal to sign, then that means it is a solid line. If it is a less than or a greater than, then it's going to be a dashed line. Okay, so that's kind of our criteria. And step 3 is to pick a point. In general, I like to pick the point 0, 0 because that's just a good common point and it's really easy to test. You can pick any point as long as it's not on the line, but 0, 0 is one I like to pick if it's not on the line. And then if it's true, you shade on that side. If it's false, you shade on the other side. So I guess step 4 is to shade on the correct side. Let's actually graph a problem here. Let's do y is greater than or equal to, so go ahead and put an or equal to there, negative x plus 4. So I'm going to graph the line. Negative x plus 4. So I'm going to cross at positive 4 because this is just in slope-intercept form already. And then we're going to go down 1 over 1. Down 1 over 1. Down 1 over 1. And I know it's a solid line. It's solid because it is a greater than or equal to. So I'm going to just connect my points there with a solid line. Kind of got off there a little bit, but get the idea. And then I need to pick where to shade. So I'm going to pick a point that is not on the line. I'm going to pick the point 0, 0. And I'm going to test it. So if I test this point, I have y is greater than or equal to negative x plus 4. So I'm going to put in the point 0, 0. So 0 for y is greater than or equal to negative 0 plus 4. So that means that 0 is greater than or equal to 4. Is that true? Well, no, it's obviously not true. It is a false statement. So we shade away from that point. So I'm going to shade above the line up here. And then you just shade it in. And that's how you do it. Next one, we have x is greater than 2y plus 4. Well, this one is not in our normal form that we're used to. So we need to do some manipulation before to get it into y equals something, or y is less than something. So I'm going to move that 4 over by subtracting 4. So I have x minus 4 is greater than 2y. Divide by 2. So what I have here is 1/2, or x over 2, times x minus 4 over 2, which is just 2, and that is all greater than y. So that's what I'm going to graph. So I'm going to graph the point, it crosses at negative 2, and it goes up 1 over 2. Up 1 over 2. And then I'm going to connect those points. More or less. And now I'm looking, what type of line should I have? It is a greater than sign. So that means it's actually going to be a dashed line. So I'm going to go back in and make that a dashed line. So on this one, you do not want to use a pen because you can't erase pen. So you're going to want to use a pencil so you can go back and erase if it happens to be a greater than or a less than sign. So we know that it is dashed, because it is greater than, not or equal to. Now I need to figure out where to shade. So I'm going to put in my point. Looks like I can still put in the point 0, 0. So that would be 0 is greater than 2 times 0 plus 4. So that would be 0 is greater than 4, which is also clearly false. So that means I shade away from that point. So I'm going to shade down this time. So I just do my shading, and that's your final answer. So this next one actually looks a lot different because there's two equations. It's a system of equations. But we graph this the same way. So we're just going to graph both equations, and then we're going to find where the whole sections overlap, and that's going to be our final answer. So if I graph this first equation, y is greater than negative 1/2 x plus 4. So I'm going to graph y equals negative 1/2 x plus 4. So crosses at 4, goes down 1 over 2, and then I connect the lines, or connect the dots. And I see that it is a greater than sign, so then I'm going to go back in and I'm going to make it a dashed line. Alright, now I need to figure out where to shade that one. So I'm going to put in the point 0, 0. So 0 is greater than negative 1/2 times 0 plus 4. 0 is greater than 4. Well, that is false. So I shade away from that. So I'm going to shade up, like that. Okay, now I need to graph the other one. So I have y is less than x minus 4. So I'm going to graph x minus 4. So cross at negative 4, up 1 over 1, up 1 over 1. And then I'm going to connect my dots and go all the way up. There we go, more or less. And again, it looks like it is a less than sign, so I'm going to make it a dashed line. So I'm going to go back in, make it a dashed line. Alright, and now I need to figure out where to shade. So I'm going to put in the point 0, 0. Yet again, I can put that point in and it'll still work. So 0 is less than 0 minus 4. 0 is less than negative 4. This is false because negative 4 is smaller than 0. So I'm going to shade away from that point. Alright, now this one, because two things had to be true, our answer is going to be our overlap. So my answer is actually just going to be this section right here, which is both green and blue. So you just shade that a little bit darker, and that's your final answer. So those are your notes on how to graph linear inequalities. Go through the practice problems. Make sure that you can graph all these different types of problems, whether it's just one or whether there's 2 or 3 or 4 equations that you need to graph. Just graph them and then find the intersection planes, and that would be your final answer. Let me know if you have any questions, and then you can prepare for a quiz over the material.